Okay, next let's define what a confidence level is. A confidence level and the next term, a significance level, are going to be two terms you're just going to see over and over and over again throughout the rest of this course. So, what is a confidence level? Well, the word confidence infers a probability of accurately hitting a target one cannot see. So earlier I referred to, probability being equal to area under a probability density function. So the probability density function is the function that defines this curve exactly. And the area under the curve is what defines probability. Now what you're going to learn is that confidence level is equal to the probability, which is equal to the area under the curve. So what you can see here between these two distributions is that, I've drawn the area under the curve between two standard deviations to the left and the right of the mean, which is in the center. And this area between two standard deviations of the mean and underneath the curve, that area we call the confidence level. So the confidence level is this area. Okay, it's another word for area under the curve. Usually, it'll be a larger number. It'll be like around 80%, 85, 90, 95, 99%. It'll be some high number typically. A confidence level is typically chosen by the student, by a professor, by the researcher, or the scientist. The confidence level is the probability that some random variability in a measurement is not significant, is not out of the ordinary, is not a rare event. So maybe to give that a little bit of context, you know, um, let's say we had a normal distribution centered around the number of donuts that people eat if they're presented with a dozen donuts to choose from. And let's say the average number of donuts, the mean number of donuts that people will take is three. They'll take three out of a box of 12. And if we were to set, um, I guess maybe like an upper bound and a lower bound as far as what we would expect to be the normal amount of donuts, we would maybe put four here and two there. So this probability in the middle would be our confidence level. And so what this means is having this confidence level, this area in between two donuts and four means that, if someone took, actually, instead of two and four, let me make this a little bit bigger. Let's say let me put one and five. That's better. So if someone was presented with a box of 12 donuts and they only took three, we would say, okay, that's not out of the ordinary. That's not a rare thing. If someone took four donuts, well, four donuts is still within this 95% confidence level defined by these two boundaries of five donuts and one donuts. So since they took four, that's not out of the ordinary. That's within randomness, that's within variation. Uh, Nothing really special happened here. If we presented someone with a box of 12 donuts and they only took two, well, two is less than the average, but it's still not out of the ordinary. It's what we would expect. Some people are going to take a little more donuts, some people are going to take a little fewer donuts, but it's still close to our average. But what if you presented somebody with a box of a dozen donuts and they just took the whole box and walked away with it. Okay. They took all 12 donuts. Now, 12 is clearly outside the boundaries defined by this area, this confidence level. 12 is way outside of 5. That is not ordinary. That is significantly more donuts than you would expect given some variation in what the number of donuts that people would typically take. So when something like this happens, that would be considered like a rare event. And that would kind of draw your attention to it. Okay, why did that person take that box of dozen donuts, right? So the confidence level, is the probability, meaning it's this area, that some random variability in a measurement is not significant. So within this range, okay, defined by the area, nothing out of the ordinary is happening. But once you choose a value outside of that probability, now a rare event has occurred, and we need to take notice of that. All right, that kind of in short is what the confidence level is. Um, and since the confidence level is usually something that's chosen, um, you'll see a lot of problems, a lot of homework problems, that'll tell you the confidence level is 90%, the confidence level is 99%, the confidence level is 95%. It'll be something that's just kind of given to you. But in the event that a problem does not explicitly state the confidence level, it's always safe to assume the confidence level is 95%. And the reason for that is that a 95% confidence level is very common. It's so common that when people write problems or they look at things in science and engineering, it's just without speaking it, people just understand it's going to be a 95% confidence level. Okay. So when you're doing the homework and it doesn't explicitly state it, that's when you can assume the confidence level is going to be 95%. All right. So the confidence level, is the area, the larger area, between these two boundaries. So what do we call the area that's maybe in the tails, the smaller area outside of the confidence level? We call that the significance level. So the significance level, denoted with SL as an acronym, or alpha divided by 2, is the probability that a value is significantly different from the mean. So remember when I was talking about donuts, and I said, well, if the average number of donuts taken is 3 and someone takes 4, that's not significantly different from the average. If someone were to take 2 donuts, that's not significantly different from the average of 3. But if someone takes 12, that is significantly different from the mean, the average number of donuts. So the significance level is a probability value that represents that something significantly different has happened relative to the mean. The significance level is denoted by this Greek letter alpha, or alpha divided by 2, and the significance level is related to the confidence level. So how are they related? So here you can see in this picture, we've got this normal distribution here, And this normal distribution has a boundary drawn in, and the boundary is drawn on a value called the critical value. And one side of the critical value is called the confidence level. So this area here is the confidence level. And the smaller area adjacent to this boundary is called the significance level. And remember that when I talked about the area under the curve, the total area under the curve has to add up to 1. So you'll see here that in this case, an area of 0.8 plus an area of 0.2, that adds up to 1. So the confidence level and the significance level kind of go up and go down together, right? As one goes up, the other goes down. So that this equivalence will always happen. The confidence level plus the significance level will always equal 1. Now, the example that I'm giving you here on this page is an example of a right-tailed distribution. So this is right-tailed because the significance level is on the right tail of the distribution. What I gave you on the confidence level page, notice here that there are 2 boundaries. That is an example of what's called a two-tailed distribution. So we don't have one boundary, we've got 2 boundaries. And where these boundaries are located are defined by these critical values. The critical value is actually the number on the number line. That number kind of defines where this boundary is located. And so you'll notice with a two-tailed distribution, we have 2 critical boundaries. One that's a positive number and another one that's a negative number. And remember what I said about how the significance level is denoted with a Greek letter alpha? So the significance level, when there's only one area, is alpha. But if we have a two-tailed distribution, we have to take this significance level and we have to divide it in half and put half of it on one side and half of it on the other side. That's where the alpha over 2, or alpha divided by 2 comes from. And if the critical value was on the negative side, then we're going to have what we call a left-tailed distribution because the significance level area is on the left-hand side. But regardless of whether we're talking about left-tailed and right-tailed, the confidence level plus the significance level will always add up to 1. And even in this two-tailed situation, the sum of all these areas is going to add up to 1. So we have the confidence level plus 2 alpha divided by 2 tails. All of that will add up to 1. Okay. So we're going to be kind of looking at that. We're going to be calculating confidence level and significant level all the time. And we're going to use this relationship that they add up to 1 all the time as well. Okay, so that's it for confidence level and significance level. Let me know if you have any questions.